Hello guys, so today we are here to solve the daily LeetCode challenge for the day, and this problem is find if array can be sorted. Okay, so this seems to be an easy problem, but there are some challenges hidden in this problem, and that's what we are going to uncover, what challenges are there and how to overcome those challenges. So in this we are given a zero indexed array of positive integers. Let's take a look at this problem. Okay, so in this we are given a zero indexed array of positive integer nums. In one operation you can swap any two adjacent elements if they have the same number of set bits. So in one operation you can swap any two adjacent elements if they have the same number of set bits. You are allowed to do this operation any number of times including 0. So from 0 to any number of times you are allowed to do the operation. Okay, and return true if you can sort the array, else return false. So see here in this, it is 8, 4, 2, 30, 15, and you see the problem is explaining in very much detail what we need to do here. So it's telling that let's look at the binary representation of every element. The numbers 2, 4, 8 have one set bit, so we have to get the set bit. Okay, 1 0 1 0 0 1 0 0 0, and then what it's doing, uh, the given number, see, we can sort the array using four operations. So see, this is 482, so it is taking swapping 8 and 2, and then swapping 2 4, and it's getting 2 4 8, and then it from 30 and 15 it's swapping 15 and 30. But see, in this given numbers 2 4 8, 30 15, this group is having the same number of bits and this group is having the same number of bits, and these two are different groups. Okay, and one more thing is that the largest number of this group is 8 and the smallest number of this group is 15, and 8 is obviously less than 15, and that's why we are able to sort it. Had it been that 15 is there in the position of 8 and 8 comes in the position of 15, then we'll not be able to sort it. Why? Because 15 is there and 15 is the largest element, and that too it's not making a group with 4 2. So there will be inconsistencies in the instance of the problem, for the and for the same reason we'll not be able to sort it. But since this particular instance of the problem is laid out in this particular way, that's why we are able to sort it. So only thing is there that for us to check that whether we are able to find, check whether the grouping is in such a way that the previous max is less than the current min. If it is like that, then we are okay. Otherwise our the given instance of the array will not be able to sorted. So with this idea we are going to solve this problem very quickly, and let me do this in a very efficient and easy way so that it's clear to one and all. So what we will do that we'll take this n is equal to nums dot length. Okay, and then what we will do that we will we will take this set bits. So int count set bits is equal to, okay, int count set bits is equal to count bits of nums of 0. Okay, and int I is equal to 0, and then while I is less than n. Okay, and what we will do here that we will check int j is equal to I. Okay, and then while j is less than n, and set bit count. So we should name this as set bits. Yeah, that's it, this is enough. Set bits is equal to set bits is equal to count bits of nums of j. Okay, and in this what we will do, so here we have to take one int previous max. Int previous max is equal to -1. We'll start the beginning of the array with -1, and then here we'll take int, and here only we will define this int current min is equal to nums of j. Okay, and int current max is equal to nums of j. So both of them are initialized with the same value. But in this loop what we'll be doing, we will be checking for each nums of j. If nums of j is greater than current max, okay, then accordingly we'll update our max with the nums of j. Else if nums of j is less than current max, if it is less than current max, then current min less than current min. Okay, then current min will be is equal to nums of j. Okay, so this is the update we are doing, and then we'll be incrementing j so that the loop is completed. And after doing this, what we will do, that we will put a check. The check is that previous max, if previous max is is less than current min. Okay, current min, then we'll return false. Okay, and now to update our loop index I, we have to go till, we can go till j, because j is creating one group. So this loop is creating one group of same set bits. Creating a group of same set bits. Okay, and this is the critical check. Okay, this is the critical check. Okay, and here we are updating the ith index. Okay, update I index. Okay, and then what we will do, if everything is working fine, then we'll be returning true. Okay, so let's run this and see with how it's performing. So we'll just run this. Illegal start of expression j is less than n. Sorry, I should have written n over here. Okay, in my hurry to do the things, I am mistaking things. Okay, I need to have the logic for count bits. So this is nothing but implementation of the Kernighan algorithm to how to find the set bits in a given number n. So what we will do that we'll do int count is equal to 0 while n is greater than 0, like this, and then n and equal to n minus 1 plus count, and then in the end we'll return the count. Okay, so let's run this. Some mistake is there somewhere. सब में false आ रहा है क्यों? If previous max nums j is greater than Okay, current max and max, else nums j is less than current min, then current min is equal to nums j plus j. That is correct. Previous max is less than current min should be greater than. So previous max is this should be like this. Previous max is greater than the current min, then we are returning false. TLE y842. Why it is TLE? Why it is TLE? Set bits count nums of 0 I less than n. Set bits count bits, ठीक है. Set bits is equal to count bits of j. So we are creating a group of the same set bits. Okay, 842. Why it is setting TLE? Why it is giving TLE? So let's do a sys out here. Eight will have 1. First is 1. I is less than n, we are updating I is equal to j. J is less than n plus j we are doing. So everything is fine. Set bits. So j is less than n, and I is equal to 0. I less than n. This is also correct. Okay. Zero. ओके, सो हम लोगों को सेट बिट यहीं पे कहीं सेट करना होगा. ओके, सो वी हैव टू update our set bit value as well. So this is coming as true. Previous max is greater than current min. Previous max is greater than current min. If previous max is greater than current min, if previous max is greater than 8 is greater than 15, then we are returning false. That is correct. Are we updating previous max? Okay, we should update the index as well as previous max is equal to current max as well. So these things we need to do, which we are missing here in this problem. Perfect. Perfect. So this is the way to solve this problem, guys. I hope you enjoyed this, and with this, happy coding, best wishes, best of luck.